Hello everyone, welcome to the discussions of the past year questions. This video we shall discuss about paper 4 mechanics 2024 October-November, paper 41. Let's take a look at the first question. Two particles of masses m masses 1.8 kg and 1.2 kg are connected by a light inextensible string that passes over a fixed smooth pulley. The particle hangs vertically and the system released from rest. Find the magnitude of the accelerations and the particles and find the tension in the string. So what you need to do is just to draw the simple diagram here to represent the smooth pulley, and you have two particles, which is the 1.8 kg over here and 1.2 kg over here. So this will be the tension. This will be the tension. Over here, I would like to change this mass into weight. So this will be 18 Newton. This one will be 12 Newton. Okay, so I call this particle A. I call this particle B. So at A, when I resolve the forces vertically, I will have 18 minus D is equal to the 1.8A. That will be my first equations. And at B, if I resolve the forces vertically, I have the T minus a 12 is equals to the 1.2A. That will be your second equations. Okay, so over here, we want to find the acceleration. Just take the equation 1 plus equation 2, add together, you have a 6 equals to the 3A. Then your acceleration is equal to the 2 meter per second square. So we found the A. Then after that, we want to find the T, the tension. You can just substitute A equal to 2 into either equation 1 or equation 2. Over here, I choose equation 1. Then my T will be 18 minus a 1.8 times 2. So just press a calculator, then you can get the answer as 18 minus 3.6, 14.4 Newton. Okay, done. That will be the answer for the question number 1. So now we move on to question number 2. Okay, now we take a look at question number 2. We have a diagram here, a particle of mass 7.5 kg starting from rest at A. So mass is over here, A. Slide down and inclined plane AB. The point B is 12.5 meter vertically below O, as shown in the diagram over here. And question part A, they want you to, given that the plane is smooth, use the energy method to find the speed at B. So we are looking for V. We know that at the beginning, your U is a 0, okay? So it's going down. So we are looking for using the energy method. So we will be using conservations of energy. We are having the potential energy loss, PE loss, is equals to the KE gain. So the formula for the PE loss, it will be mgh equal to the half m of the V square minus a U square. So we can cancel the m. We will have a V square is equal to the U square plus 2GH. So our U is a 0, the G is a 10, and the height is a 12.5. So therefore, you get the answer is 5 square root of 10 meter per second. Okay, you can just use your calculator, simplify them, and you get the answer V as a 5 sub 10 meter per second. Okay, so now we move on. B, it is given instead the plane is rough. Just now it's smooth, now it's rough. And the particle reaches B with a speed 8 meter per second, and the plane is 25 meter long, and the constant frictional force has a magnitude of F. Find the value F. Okay. So for these questions, it's not require you to using energy method anymore. Of course, if you want to use energy method, you still can use it. But over here, I do not plan to use energy method because I have the U as a 0, and I have the V as 8. I have the distance traveled is 25 meter, and I have the frictional force. So over here, we can use A equals to the V square minus the U square over the 2S to find the accelerations. So it will be X square minus the 0 square divided by 2. S is 25. And when you press a calculator, you get 1.28 meter per second square. Okay, so I found the accelerations. Okay, now if you resolve the forces parallel to the plane, then you will get mg sine theta minus the F is equals to the ma. Okay, so your m is 7.5. The mass is 7.5 kg. Then the g is a 10. Your sine theta, so we need to deal with the sine theta, okay, because the question mentioned that this is a 12.5, this is a 25, then this is the theta. So I need to mention the sine theta. So the sine theta is actually 12.5 divided by 25 is a half. Sine theta is a half. So we can just put it like this: half minus the F is equals to the 7.5 A. Press the calculator. We have found the A actually. Our A is 1.28. So just press the calculator, simplify, you get the F as 27.9 Newton. Done for this questions number, example, question number 2B. So now we move on. We will go for the question number 3. Okay, now we take a look at question number 3. We have another diagram over here. Coplanar forces of magnitude 52 and 39 and Pn acts at a point in the direction shown in the diagram. The system is in equilibrium. Find the values of B and theta. So what you can do is that we resolve the forces vertically. Then you will get the 52 is equal to the B sine theta. Okay, or we can just write B sine theta equal to 52. Okay, it's better we let B sine theta equal to the 52. That is your first equations. Then if you resolve the forces horizontally, you have P cos theta, then actually it's a 39 minus P cos theta. 39 is equal to, is in equilibrium, sorry, is in equilibrium. So there's no need for you to write like that. We can just write P cos theta is equal to 39. That will be your second equations. So to find B, just take the number 1 square plus the number 2 square. Then you get B square equals to the 52 square plus the 39 square. Press the calculator, simplify it, you get your P is a 65 Newton. Okay. So P is a 65 Newton. Only the right Newton because here already have Newton. Then we want to find the theta. To find the theta, just take the number 1 divided by number 2. Then you will get tangent theta is equal to the 52 over 39. Press the calculator, then you can find the theta. And your theta will be 53.1 degree. Okay, so done. We are done for these questions number 3. Now we move on to the question number 4. Okay, now we take a look at question number 4. A bus travels between 2 stops, A and B. The bus starts from rest at A and accelerates at a constant rate of A meter per second square until it reaches the speed of 16 meter per second. It then travels at this constant speed before decelerating at a constant rate of 0.75 A meter per second square, coming to rest at B. The total time for the journey is 240 seconds. So we just need to draw the diagram like this. Accelerating, the first stage, you accelerate with these accelerations at A meter per second square until you reach 16 meter per second. The question didn't mention how long it takes for you to accelerate, so I call this one T1. And then after that, remain this constant speed for a certain period of time. I also do not know what is the period of time. I also do not know the time taken for remaining the constant speed. Then after that, they're telling you that it starts to decelerate until it comes to rest here. And they say that the total time is 240 seconds. So this is what the diagram you can apply. This is what the diagram you can draw. Done for the part A. Now we're going for the part B. Find an expression in terms of A for the length of time that the bus is traveling with constant speed. Okay, so we want to know the T2 minus T1 equals to 1 in terms of A. So this is the question for part B. So what you can do is that the first stage over here, we know that the acceleration is 16 over T1. Okay, and our T1 is a 16 over A. That is the first stage. And for the last stage over here, okay, we know that the deceleration A is 0.75 A, the deceleration, but it's negative. It's negative because it's deceleration. So what you can do is that for the last stage is negative 3 over 4A is equals to the 0 minus the 16 divided by 240 minus the T2. Okay, so you can have 240 minus T2 is equals to the 64 over 3. This is A. Divide A. Okay, then your T2 will be the 240 minus the 64 over the 3A. Then therefore, T2 minus the T1 is equals to the 240 minus the 64 over 3A minus the 16 over A. Okay, and we can combine them together further. So you have 240 minus the 112 over 3A. That will be the answer for the part B. Moving on, they are telling you that the distance is 3,000 meters. Find the area, find the value of A. So the total distance is 3,000 meters. So this one is that the total area under the graph is equal to 3,000. So what is the formula for the graph here? Area of the graph is a trapezium. So it will be half multiplied by the base 240 plus the T2 minus T1. multiply by the height, you get 3000. Okay, so expand and simplify. You will get this one as the 480 minus a 64 over 3a is equals to the 375. Then press a calculator, you can get the answer A as a 16 over 45 meter per second squared. Done. That will be the answer for the question C. Moving on, we have question number 5. Okay, now we take a look at question number 5. A particle A is projected vertically upward from a point O with a speed of 80 meters per second. 1 second later, a second particle B with the same mass of A is projected vertically upward from O with a speed of 100 meters per second. At the time t second after the first particle is projected, the two particles collide and coalesce to form a particle C. Show that the t is equal to 3.5. So what you can do is that we start from A, particle A. Okay, and if you resolve the forces vertically, you have the HA is equals to the 80t minus the 5t squared. Okay, using the formula, the vertical displacement. Okay, then when at B, and if you resolve it vertically, you have a HB is equals to the 100 t minus 1 minus a 5 t minus 1 square. What is the reason we want to use t minus 1? Because you actually projected 1 second later compared to A. So you put t minus 1. Don't put t plus 1. Let's put t minus 1. Okay. So now that is your first equation. That is your second equations. When the time t equal to t, okay, your HA and HB are the same because they say they collide. Okay, so you will have 80t minus a 5t squared is equal to 100t minus 1 minus a 5 of t minus 1 squared. So we just need to expand and simplify it. You have 100t minus 100 minus a 5t squared plus the 10t minus the 5. So this one cancel off. So simplify everything. You will get this one as a 30t is equals to the 105. Then your t is equal to the 3.5 shown. Okay, so done for the part A. Now we're moving on. Part B, the height above O at which the particles collide. Okay, so when t is equal to 3.5, okay, so the height above O, we can just put in either HA or HB, that is up to us. So we just put HA is equal to the 80 times 3.5 minus the 5, 3.5 square. And just press a calculator. You will get the answer as I prefer to leave the answer in fraction form, exact value form. So it's 875 over 4 meter. Of course, you can also always make it become a decimal place. You can make it become 218.75 meter. That will be the answer for the B. Now for the C. Find the time of A being projected until C return to O. Okay. A being projected until C return to O. Okay. So we the A and the B, they projected at the same spot. Okay. But 3.5 seconds later, they coalesce. They need to, how to say, they collide and then they coalesce. Okay, so we need to know the speed of A and the speed of B. Okay, before they collide, the velocity of A and the velocity of B when they collide. So at A, we are using the formula VA equal to the UA minus the GT, okay? So it will be 80 minus the 10 times T is 3.5, okay? So if you press the calculator, you get this one as 45 meter per second. Then at B, you also do the same thing. It will be the UB minus the GT minus 1. Okay, T minus 1, not D, because B is projected 1 second later than A. So this one is a bit tricky. So it's 100 minus the 10 and 2.5. 2.5 is a 5 over 2. Okay, so if you press a calculator, you get 75 meter per second. So you can see both of them is having positive, the value, the VA and the VB is both having positive. That means they're actually both in the same directions when they collide. Okay, so now we can use the principle of conservation of linear momentum. That mass of A, they mentioned, that question mentioned that the mass of A and the mass of B are the same, same mass. Okay, so the mass of A is the same. So M UA plus the MUB is equal to the M plus M VC. Okay, oh, I'm not supposed to use UA. I'm supposed to use VA and VB. I'm supposed to use this formula. So the M and M and M and M can cancel. So you have a VA plus a VB is equal to the 2 VC. So my VC is the velocity after they combine together. You will get this one as the 60 meter per second. That is the speed of both of the particles combined. Then after that, they return to O. Okay, so when they return to O, so the spot over here just now we found, okay, just now in part B, this is the particle C. When they combine already, just now we found that the height is this height, 875 over 4. Okay, so this one is 875 over 4 meter, and you are going upward with the 60 meter per second. Okay, so what happened over here is that the particle will continue to move until it drop to the ground. Okay, so what I need to do now is for the particle C, for the C, we have S equals to the 60t minus the half GT square. Okay, and when your displacement is negative 875 over 4, you have negative 8, this one is negative 875 over 4 is equals to the 60 t minus a 5 t squared. We will be having a quadratic equations over here, but first of all, let me just multiply everyone by 4 and then divide 5. If I multiply everyone by 4, divide 5, I get 4t squared minus the 48t, and then minus the 175 equal to 0. You can use a calculator to get the answer. Your calculator will give you t is equal to 14.93. Okay, and another one, t is equal to negative 2.93. We know time cannot be negative. We ignore this value. Okay, so therefore, the total time is equal to the uppercase T plus the lowercase t. Uppercase T just now was 3.5, and the lowercase t is 14.93. So the total will be 18.4 seconds. So because the time it reached, the time over here is the 14.93. The time for you to reach from here to here, it takes you 3.5 seconds. So the total time you need to add together, you get 18.4 seconds. Done. That will be the answer for the question number 5. And moving on, we have question number 6. Okay, question number 6. A particle of mass 1.2 kg is placed on a rough plane with an incline at an angle theta to the horizontal, where the sine theta is equal to the 7/25. The particle is kept in equilibrium by a horizontal force of magnitude P acting in a vertical plane containing the line of the greatest slope. The coefficient of friction between the particle and the plane is 0.15. Find the least possible value of P. So first of all, we are having a sine theta here equal to 7/25. I will draw a small triangle here. This is a 7, this is a 25. Pythagoras theorem telling you that this is a 24. Okay, so we will make use of this. I will redraw again my diagram, pointing the force P go outward from the particle. This is the weight, 12 Newton. This is your normal contact force R. And your frictional force is going up or going down. So this one we can investigate over here. So this is the plane. This one is the R. This one is the 12 Newton. Okay, so now the problem is where should we represent our frictional force? Okay, so is the frictional force go up or the frictional force should go down? They are looking for least value of P. So the least value of P, that means they want the P as minimum as possible. So if they want the P to be minimum as possible, that means the frictional force supposed to be same directions with the same direction as P when they resolve it parallel to the plane. Okay, so you need to make your frictional force go up like this, because if you resolve the forces this way, then it will be P plus F. P, it will be P, this is the theta. This is the theta. It will be P cos theta plus F, then equals to the 12 sine theta. Okay, then your P will be minimum. But if you treat your F going this way, then it will be P cos theta minus F. Then your P have to be bigger already. Okay, so over here, we need to know the meaning of the questions. So that means we will make our frictional force going upward. So this one is P plus F sine theta. Sorry, we're supposed to find the normal contact force first. So to find the normal contact force, we resolve the forces this way. So we have R is equal to the 12 cos theta. By using the right angle triangle diagram, is a 24/25. And we press a calculator. Oh, sorry, I resolved the forces are not complete. Okay, I forgot the P. Okay, so the R is actually equals to the 12 cos theta plus P sine theta. So you are having 12 multiplied 24/25 plus the P multiplied 7/25. So this will be a bit troublesome over here. We just need to join them together, become 288 plus the 7P/25. That is your R. First equations. And now I resolve the forces parallel to the plane. I will get the P cos theta plus F is equals to the 12 sine theta. But we know that you to get the least value, so you must assume that this you must make this as a maximum frictional force. That means you can use mu r, okay, plus the mu r. So your mu is 0.15. Okay, this is a 12 of sine theta. Okay, so I just call this one 2. 1 into 2, I get 24/25B plus the 3/20 R. 288 plus 7B/25 is equal to the 12 times 7/25. Okay, so we can actually just combine everything together. Okay, so I will get 501 over 500b using calculator lah. Then you can get this one as a 84 over 25 minus the 216 over the 125. Then press the calculator, simplify again, you get your P as a 272 divided by 167 and is equals to the 1.63 Newton into 3 significant figure. Okay, so this will be the answer for the question number 6. And moving on, we have question number 7. Okay, now we take a look at question number 7. A car has a mass of 1,200 kg. When the car is traveling at the speed of v meter per second, there is a resistive force of the magnitude of kV Newton. The maximum power of the car engine is 92.16 kilowatt. Part A, the car travels along a straight horizontal level road. The car has the greatest possible constant speed of 48 meters per second. They want you to show that the K is equal to 40. So since it's moving in a straight horizontal road, then we will go for the resolving the forces horizontally. You will have a driving force minus a resistance force equals to the MA. Okay, so your driving force is actually P over V, the formula. Resistance force is a kV, Newton. The mass is a 1,200. And the A, over here, actually the A is a 0. So we do not need to write the MA anymore. This is a 0. Just need to explain that because of you are having constant speed. So over here, the P is 92,92160. If you multiply the 1,000, then the V is 48 minus a K times 48. So just by using calculator, you can show that the answer for K is 40. Shown. Okay, done for the A part 1. Now we're moving on to the part 2. At an instant when the speed is 45 meters per second, find the greatest possible accelerations. Okay, so when the V is equal to 45, then we're still using the same formula like over here. We're still using the same formula here, but this time the A is not 0. Okay, so we will be having the P over V minus a KV is equal to MA. P is a 92160. V is a 45. K we have just found in part 1 is a 40. Then the V is 45. This is a 1,200 and the A. So just pressing the calculator, you can find that your A is 31 over the 150 meter per second square. Just like that, done. Now we move on to the part B. The car now travels at a constant speed again, up the hill incline at an angle of arcsine of 0.5. That means the theta is an arcsine of 0.15. That means the sine theta is a 0.15. So they want you to find the greatest possible speed of the car going up the hill. Okay, so if you're going up the hill, then you have a driving force minus the weight mg sine theta minus a frictional force is equal to ma. So it will be P over V minus a mg sine theta minus a kV is equal to 0 because of maximum speed, greatest speed. If you want to get greater speed, your accelerations will be 0 as well. So the P still the same, 92160. The V over here, you do not know. You need to find the V. The M is 1,200. G is a 10. Sine theta is a 0.15. K is a 40. V is do not know. Just having the equation like this. Then I just need to multiply everyone by V, I get 92160 minus the 1800 V minus the 40 V square. Just use the calculator to find the quadratic equations to solve the root. Okay, so this is what we are having. So just press the calculator only. So your V will be equal to the 30.5 meter per second. This one is correct to 3 significant figure. And another V will be negative 75.5. This negative value, we will ignore it because your car is going up the hill. So it's positive. Okay, so that will be the answer for the question number 7B. And now we move on to the question number 8. Okay, now take a look at question number 8. A particle P move in a straight line passing through a point O with a velocity of 4.2 meter per second at time t second after P passes O, the acceleration is A, and is given that A is equals to 0.60 minus 2.7. We want to find the distance traveled between the time at which it is at the particle is at instantaneous rest. So instantaneous rest means the velocity is a 0. So in order to find the time, we need to have a velocity first. And to get velocity, we need to integrate the accelerations. So if you integrate the accelerations, you will get this one as a 0.3 t squared minus a 2.7 t plus a c. Then it's given in the questions when t equal to 0, the v is equal to 4.2. That will give you the c is also 4.2. So now just put the c back here, 0.3 t squared minus a 2.7 t plus the 4.2. Okay, this is what we have. Now to find the time for instantaneous rest, we let the v equal to 0. Okay, so we have a 0.3 t squared minus a 2.7 t plus the 4.2 equal to 0. We can also use the calculator to help you to get the answer for solving the quadratic equations. So from here, your calculator will give you t equal to 2 and t equal to 7. Okay, so this will be the true time that your particle is at instantaneous rest. And if you look at the diagram, if you try to put the value into the VD graph, draw the VD graph and try to put the equation inside, you can see that the graph is actually a quadratic that is having a minimum point over here. So in between of 2 to 7, you can see that your graph is below the t-axis. That means it's below the horizontal axis. Your area will be negative. So we know that the area is a distance. So later, when we want to find the distance of P, the distance value will be negative. And to find the distance, we need to put modulus in order to get a positive value. Okay, so over here, we just write S is equals to the modulus of integrating 2 to 7, the velocity that we have found over here, and then plus a 4.2 dt, and put the modulus again. So now we just need to integrate properly. 0.1 t cubed plus a 1.35 t squared plus the 4.2 t. 2 to 7, we put the modulus over here. So we get a 0.1343 plus 1.35 of a 49 plus a 4.2 of 7 minus the 0.1 multiplied by 8 plus the 1.35 multiplied by 4 plus the 4.2 multiplied by 2. Okay, and the whole thing here, we modulus it. Okay, the whole thing here, we modulus it. So we just need to press the calculator. A lot of values over here. So the calculator can be very helpful over here. Just press the calculator, then you will get the answer as supposed to be modulus negative 6.25. But the modulus, the purpose of modulus is to make it become positive. So I just direct write my answer as 6.25 meter. Done. That will be the total distance traveled by the particle between the two instantaneous rest of time. Okay, so I will stop the video here. This will be the last questions for this paper, and I will stop the video here. I'll see you next time in another paper. See you then. Bye-bye.